Hey guys, welcome to this lecture on embedded C programming. So today we are going to talk about the RTC alarms and RTC clock that are embedded inside the microcontroller. So the microcontroller that we are going to use today is STM32F446RE. Basically, I have a nucleo board with me, so I am going to perform that this experiment on that nucleo F446RE board. So let's get started. So basically, what is an RTC alarm? So or the RTC clock. So RTC clock is basically the real time clock that run behind the picture, right? So in future or today, if you are dealing with the projects of RTC or the clock based project, so in those projects you have to use these clocks to measure the time or to perform an time based event, right? So by time based event you can understand it a little bit easily by this example. So the example is that let us assume that every day at 10 o'clock you have to blow a horn, right? Or not the horn, the buzzer, right? You have to blow the buzzer at every 10 o'clock every morning, right? So to perform this experiment you have to use a controller that will or will not be having an RTC, because this I am saying because most of the controllers these days have the RTC engine embedded inside the chip only. But yeah, there are some kinds of controllers those does not have such kind of functionality inside it. So we have to use a different RTC module for that, right? So basically today we don't have to use any different kind of module. We'll be using the onboard RTC engine. So let's get started with the project. So today the aim of the project is that we have to set a time, right, and show that time on the Teraterm software, right? And exactly after the 15 seconds or the 20 seconds I have to blow an alarm. So basically I'll not be using a buzzer, so I'll be using the onboard user LED. So by using that user LED, at exactly after 10 to 20 seconds I'll be setting an alarm, and after 10 to 20 seconds when that alarm gets set, the LED will glow on the board, right? So this is the main aim of this project, right? So let us start with the project. Basically this is the cube IDE that I have downloaded. So basically you can also download this ID from the STM32 cube IDE software, right? Basically STM provide this ID on their website, so you can visit the STM website, ST Microelectronics website, and you can download this software, or you can view our previous videos. In that videos I have shown you how to download it. So let's get started. Let's start a new STM32 project. So here I have to press this board selector and choose the respected board. So yeah, we have to use this nucleo board, this one over here. You can also download the data sheet from here and the reference manuals, right? Documents from their online website also, or you can get it from here. So yeah, I can show you a large picture also. Okay, so you can see from here also. So actually there is an user LED over here, right? So this is a green color user LED which is present on board, and over here we have a red color LED that is just a power LED. So that power LED shows us that our board is on or not. Actually that is for that our board is getting a sufficient power. Actually we can't use this LED, so we have to use this user LED only, right? So yeah, this is the F446RE microchip that is onboard chip. So we have to program this chip with the help of the ST-Link circuitry. So let's get started. So I'll double click on this. So over here we can see that we have to enter the name. So I'll be entering this name RTC clock. Over here I have to choose the location. You can choose whatever location it is. So language I'll be using C, and binary type it must be exe executable, and the targeted project type. Okay, so this is very interesting. If you people want to use that software of STM that is provided by the STM only, so the software is called CubeMX. So you people can differently download that software on your computer, or you can just click on STM32 cube and click next. So it will open a STM32 CubeMX type software. So basically what we'll be using is that software only. Actually MT is for those people who want to write their code from the scratch, right? So they don't want to initialize their code from that STM32 CubeMX software. So basically we'll be using that only. Why I am saying that we have to use that software, because it makes us very easy, right? So we people don't want to make things complex, right? So we also have the time constraint also. So in future if we get time, I'll be using this empty or empty project type also, because over here we have to code from the scratch. Over here we don't have to code. Start with next. Yes, I have to open this. Okay guys, so our CubeMX has been initialized. So let us see what we get over here. So actually we are getting STM32F446RE chip overview. So yeah, you can click over here and check what kinds of pins there are available on the board or the chip. So basically over here you can see that at PF5 we have a green LED over here. So you have to check this out. If it is not checked, you can go over here or click on it and get the GPIO output, get it as GPIO output. So it will work as the same, because we have to set the mode as of output over here. So this is the UART TX and UART RX. These two pins we'll be using to send our data to the Teraterm software, right? Actually from this chip to the Teraterm software we need some mechanism, right? We need some route to send that data. So we'll be using the UART peripheral, right? So yeah, we have the UART TX and UART RX over here. And the next thing, we have a push button, right? If you need to use that push button you can, but yeah, in our case it will be not so necessary. So we'll basically be using the reset button only. So it totally depends on you. You want to keep it, you can. If you don't want to, no problem. That is completely fine. So basically I have to go to timer, and then the RTC. I have to activate the clock source. I have to activate that calendar also, and yeah, I have to enable the internal alarm A. Right. So over here we can see that we get the two kinds of alarm. So it is alarm A and alarm B. So no problem. We'll be using a single alarm also. Basically at a time you can use two alarms also. So no problem. We'll be using the single alarm, and in the NVIC setting, yeah, you have to set that interrupt, right? Basically we'll talk this inside the project only. So this is a kind of interrupt that will get generated at the time of alarm. So we will be using this interrupt, and here is a column that is the parameter setting. So yeah, you can set the time, the calendar, the date, alarm A also, right? So you can set those things over here, but yeah, we don't need that over here. We'll be setting those values inside our code only. So no problem. If it depends, you can. If it don't, you don't need to, right? Basically just check one thing, that is your UR2 peripheral checked. Yes, it is checked. So yeah, we can use the UR2 peripheral to send those time values through our controller to the laptop, or basically the Teraterm software, right? So no problem. We have everything over here. So yeah, now we can proceed next. We have to go to project manager. Okay, so the clock configuration, let it be inside the clock configuration. If you say then RCC, it is high speed clock and the low speed clock, right? It totally depends on you what kind of clock frequency you want and what kind of clock frequency you don't want. So in my case, let it be like this only. So let's go to project manager. Okay, the project manager, the name is clear, and the tool chain is also cube IDE, no problem. Tools, we don't need to see this. Okay, 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 pinout configurations, no problem. So basically you can go to our this block and click on it. Do you want to generate code? Yes, I have to. This section can be associated with C++. Do you want to open that perspective now? Yes. So over here we'll be getting the C code that is basically generated by that software that I was talking about earlier. So over here we can come down and let's see what CubeMX has given to us. So okay, so basically, first of all, let us talk about this perspective. What at all they are giving us, right? So we over this section we have the code, right? The code name, the source file, the binary files, and the other things, right? So we'll be getting those things over here, and over here this console, the build values will be given over here, right? Whatever warnings and whatever errors they will be generating, it will be all be showing over here. So now let us check the code, right? This is the main body of the code. So accordingly you can see there's a lot of code that is being generated from the CubeMX only. You people can now make an idea that how much time that CubeMX has saved for us, right? If we talk about what at all they have provided, let's talk about one by one. So here's the int main, right? This is the main. Actually, this is the main space that we'll be using to write the code, right? So it gets started from here and it gets end over here. We are also getting a while loop to execute our code, right? So multiple times, right? So to execute our code multiple times, we can add that code to the while loop also. And there are some others initializations that are given, like the system clock config, the HAL init. Like the HAL init is basically the whole library that we will be using over here to program, right? And system clock config is basically nothing, the all the kinds of clock configurations that we need. So basically these things, these configurations and inits, we can perform this on in CubeMX also. So right, we have done that, so we don't need to perform any kind of init over here, so they have already done it. Yeah, there is UART2 init also. UART2 I have talked about it earlier also. Actually UART is basically a mechanism of communication between the IC and your computer, right? We'll be using that UART peripheral to communicate our computer or the PC with the board. So RTC init, let us check what is there inside the RTC init. So if I open the declaration, so in the RTC init, we get these kinds of code that is generated from the CubeMX. So there's a whole lot of code. So I was talking about the time and the date and the alarm. So that thing is available here. So actually you can type your hours over here and your minutes over here and your seconds over here. So if we talk about the format, right? So basically there are two kinds of format that our code use, our RTC use. So the RTC used BCD format and the binary format. So it totally depends on us that which kind of format we want to use. So this is the BCD format. So let us change it to binary, right? Actually this thing you can also do on CubeMX software, but no problem, you can change it over here, it will automatically get changes, right? No problem. So BCD format will get changed to binary. We'll be using the binary, so we can remove this zero cross from here as date, right? And the zero. Okay, so this now, from now on, this becomes the binary variables, right? Actually you can type in the decimal and the RTC will check it out in binary, right? It's not the RTC, the chip. Now what we are going to do is we'll be this whole code in our main, right? What we can do is we'll be copying this code from here. Okay, so I have copied it from here and I am going to paste it in the main over here. So yeah, I have pasted it over here. So basically what we are going to do over here is that we are going to set the time, the date and the alarm over here, and we'll be getting those value from the RTC and sending it to uh, the Teraterm software, right? With the help of UART. So okay, now let us see that what other things we need over here. Basically we'll be needing these structure variables also. So yeah, they have defined it over here. we can pick those variable from here and paste it just above this code, right? So yeah, these are the structure variables. So with the help of these variables we can we can make use of the types of data that is already available inside the structure. So what are the kinds of structure? So basically what is there inside the RTC time def. So yeah, time def structure includes these kinds of data types, right? So there are minutes, there are seconds, there are time format, sub-seconds, fraction. If you people want to change these parameters, you can come over here, read about them, and then change them accordingly, right? So yeah, the hours over here specifies the RTC time hour, and this parameter must be in between minutes data 0 to max data 12. Yeah, basically there are two kinds of format available inside the code. So inside the RTC, they are 12-hour format and they are the 24-hour formats. So if your people are thinking that where we have set those formats, let me show you that where we get those formats. When we come down to this RTC init, so we can see over here that RTC format 24, right? So we have actually chosen the 24-hour format. It totally depends on you what kind of format you want to use. You can even use the 12-hour format also. So this is the format that I was talking about earlier. So no problem. And these are some kinds of pre-scalars, right? So yeah, if you study that the reference manual of this IC, and you particularly go to RTC section, you will getting to know that what are the pre-scalars. So basically we don't have so much time, so we'll be stopping this right now. For the time being, you just understand it like how I am telling, right? Now we'll be going up, and we'll be setting the alarm and the time. And over here also I have to change it into binary. Yeah, now it's clear. Okay guys, so let us check that what are the uh, prerequisite for this code. So yeah, you basically have to do nothing, you just have to set those value over here, right? So let us set the time first. So what must be the time? Actually we are using the 24-hour format, so let us choose a time accordingly, right? So let us make the time as 23, and what is the last minute? That is 59. Make the seconds to 45, right? So actually if you notice it clearly, so it is basically the last 15 seconds left for the day, right? So after this 15 seconds our day will change. So let us see by coding this time. So do our day changes actually or not, right? Let us also set the day also. So on day, let it be Monday, no problem. Basically after the 15 seconds, it will be changed to Tuesday, right? So and the month, let it be January, no problem. As date, let it be the first day, right? So you can change it accordingly how you want it. Basically if you go to declaration, not this declaration, so you will be getting to know that what kind of data you have to put in inside this data type, right? So you can read this structure and you can get to know a whole lot of data values that you have to enter. Okay, now let us go back to our code main.c file and check what other things we have to enter. Okay, so the day is selected, the month is selected, and the date is selected. Now let us select the year, right? So year basically be like some values. Let us see that what is the year that we should select. So in year, specify the RTC year, and this parameter must be a number between the minimum data is 0 and maximum data is 99. You people might be thinking that how we'll be entering the year as 2019. So you don't have to enter that, you just have to enter the 19 or 20 or 21. So basically 21 is going on, so you will be entering the 21, and if you want to print that, you will just be adding the plus 2000 sign over here, or you can just add 2000 plus by years, right? So it will automatically becoming the 2009 2021 or 2019. Okay, so yeah, this was the thing that I have to tell you. If I talk about the year, so let me type it as 21. The year will get the 21 value, and if we want to print this, so we'll be adding 2000 to this value of 21, and it will automatically be getting printed wherever we want it. Like it may be the Teraterm software, it might be an LCD, it might be any kind of screens or any kind of data, right? So now let us check what other things we need over here. So in the bottom side, people are seeing that there is enable the alarm functionality over here, like over here. So let me go over here and see what is the alarm that we need to set. Let us set an alarm accordingly, right? So let us set an alarm in a new day, right? Like if I have set the time like this, so there are only last 15 seconds left for the day. So let us select a new day alarm. So let it be 0, hours will be 0 for the new day, minutes will also be 0. So let us select the seconds as 10, right? Yeah, 10 is okay. Now why I have selected 10? So because after the 10 seconds of the new day, alarm will flash, right? So basically by flash I mean to say that the LED will glow. So that LED glowing will be showing us that alarm has got blown, right? There are some other parameter setting that we accordingly have to do, like the daylight saving, store operation reset. Okay, so this is basically a thing that we need to see over here. Basically we have to choose the alarm mask, right? So what is the alarm mask? Basically by mask we understand that we have to check each and every value, like if I have choose alarm none, so this means that the day and the year and the uh, date, these three things should match with the alarm, right? So basically that is not the condition over here. Basically alarm is blowing at the next day, so we have to choose a different value over here. So what is that value? We'll be clearing over here and choosing the date week day over here, because we have to mask these three values. We don't have to give attention to this value to blow the alarm, right? So date week day will get selected over here, and by doing this we'll not be giving attention to these three things. Okay, so regardless of whatever the date is, whatever the week is, and whatever the day is, the alarm will blow at this time, right? So time should match and date should not, right? So the main motive of saying this is that time should match and date should not match, right? Okay, so basically date will change now after 10, 15 seconds, date will automatically change, right? So that's why we have choose this. And other things like date week day alarm, RTC alarm A, that is clear, no problem. You can remove this from here, no problem. Okay, so now it's clear, right? It's good. So our time is set, our alarm is set, our date is also set. Now is the time to send these time values to the computer. So basically before doing that, let us see that is our code compiling good or not, right? So for doing that, just right click on this RTC project and just click on this build project. Okay, so you can automatically so you can see that our build has shown the results, so there are no errors and no warnings in our code, right? So yeah, so now let us see that what other things we have to include inside our code to show that data uh, data to the Teraterm software, right? Let us do some kinds of initializations to show that data, right? Basically, what initializations you need a buffer. That buffer will be storing your message. So what is your message? Your message is date and time. We'll be showing that date and time accordingly inside our Teraterm software. So to do that, let us go upward, come to the global space, and over here you just select a buffer, right? So let me select a buffer as char, let it be message. Buffer name must be something, right? And the buffer space, it should take around about let us keep it 100, no problem. There must come the 100 values inside this message, right? So no problem. So 100 is enough space to enter our data, right? Let us also initialize a variable. Let it be u int 8 underscore t size. So basically this size will be uh, used inside the UART peripheral, right? UART peripheral. And let us come to the main code. So yeah, now this code, we have to enter this inside this while loop. So why we have to enter this inside while loop? Because this is a repetitive process, right? After every 1 seconds the time gets changed, and that time is get reflected inside our Teraterm software. So this is the case, right? So let us type something, and you people can show our you people can see over here, so that you can understand the code that what I have written. So let me write something, and you people just see what I am writing, and I'll be explaining those things after I finish typing. Okay, guys, so what I have typed over here is the get date API, right? So this actually function calls the date from here, and it gets shown over here, right? So there are three parameters that it is taking: the handle variable location, and the s date structure variable, and the RTC format. So yeah, these are only the three things that we need to pass to this function. So basically I have defined a variable over here that is size. Let me type that variable size equal to uh, it is equal to is the sprint. This function actually returns the size of the data, right? So let me type something, and that then I'll be explaining you. What I have done over here is I have passed these kinds of parameters inside the sprintf. So basically these all data is going to store inside this message, and this sprintf is going to return the size of this message, right? So yeah, so basically this is the main motive of using sprint over here. And let us okay, so year is not correct, it is clear capital Y. And now it must be clear, right? State dot year, state dot month, and state dot t. So these three variables going to store inside the respective percent d positions over here. So let us send this date to the Teraterm software. This thing over here helps us to send the data from the UART peripheral software, right? So this is basically the date that we have sent from our microcontroller to the Teraterm software. We actually over here I have typecasted it to the address, so I have to use this star over here. So now it's so this message is transmitted to the UART from the UART2 peripherals to the. So this is basically what we have to use to send the date. Now I have to send the time also. So for the time, everything is same. So I am going to copy. Okay, so I have copied it, and I am going now. I just have to change this. So now I don't have s date. Now I have actually this is the structure variable. So yeah, this is what I have to type here, and inside the size I have to change this whole line, and in place of this I have to write s time dot hours, s time dot. Now hours is typed in. Now it's time to type the minutes, right? Minutes. And after this I have to choose as time dot seconds. Now I have to transmit this data from the UART variable. Now this time this message will get populated with this kind of data, right? So earlier there was date inside the message, and now it will be time inside this message. So no problem. So I have given a delay of 1000, right? So why I have chosen this time? Because I have to change, basically that value will get changes after every second, right? So that's why I have chosen this. So after every 1 second the updated time will get displayed inside the uh, Teraterm software. Okay, now let us build this project and check whether it is working or not. Okay, so we are getting some kinds of warnings and error over here. So let us see what are those errors. There were a lot of errors, so it took me some time to figure out those errors and warnings. So finally I have done it. So yeah, there is one warning that last warning that is left over here. So that warning is implicit declaration of function sprintf. So this is because I have not used this library stdio.h. So you people should give some attention over here, and accordingly you can use this library. So now if I build this, so okay, so this warning is also gone, and there were other error also, because those errors were because of this address value. So as I have not used this ampersand over here and over here also, so that's why there were a lot of error. So now I have changed those values, so you people can see and accordingly type those values over here. So and the other error was because I have not used uh, time over here. So it was actually date only, as I have copied it from above. So it was date only. So that was also an error. So yeah, so these were only the errors that and these were only the changes that need to be implemented. So they are all implemented. So now our code is also building successfully and there is no error. So why not test it on our board? Okay, so let us test this much of code and then see what happens. So to test it, let us go to debug as and STM32 Cortex M66, and okay, so the name is like this only, and go to debugger and select the serial wire debug over here, enable, sorry, the serial wire viewer, and apply it. Okay, and now a pop-up will come over here to switch to the debug environment. Okay, so we can now press switch, and it will get switched to the debugging environment and the code will get updated. Okay, so the code is updated. Now I I just need to open the Teraterm. So let me find the Teraterm over here, and okay, I have to select the serial, and let us go to setup, serial port, just click it 115200 and press OK. Now if I press this reset button, so my time will get printed over there. So basically you can see that time is also getting printed and the date is also getting printed. Okay, so now uh, as as it is sending the date and time. Okay, so it is only printing the date, right? Actually one is time and one is date, right? So let me check what is the problem. Actually the problem is I have copied it from above and I have not given that attention to change the time, right? So I have kept it as date, right? Here is also date and here is also date. So let me change it to time. And now again let us go to C++ and click to build project and update it to the board. Okay, so now let me press this reset button. So now you from here you can see that time has got printed. One is date and one is time. So okay, now the thing is that there is some problem, right? No, there is nothing. Okay, so the date is also printing and the time is also getting printing. This is awesome, no problem. Okay, so 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 we need to check whatever the problem. And actually, yeah, no, there is no problem, right? As our time has changed, the date has also changed, right? Let me click reset once again and then let's see what is happening. Actually you can see that the time over here is 23:59:45 and date is 11:21. So now let us see that does this date gets changed when the time reaches to 60, right? Okay, so 60 means 0 and our date has also got changed to 121. Yeah, so over here you can see that it has changed to 121. So this is awesome, right? So yeah, actually this is handled automatically from the this QMX. Sorry, not the QMX, the RTC engine. So it is automatically handled. So now let us set an alarm, right? So let us set that alarm, and to set that alarm, basically by setting alarm, I mean to say that you have to generate an interrupt, right? So to generate that interrupt, you have to go to it.c5 of this code over here, and below the itc.c5, yeah, we have an RTC alarm IRQ handler. So this is basically the interrupt handler, right? So we have to they have written that this function handles the RTC alarm A and B interrupt through EXTI line 17. So yeah, EXTI engine basically deals with the external interrupts or the interrupts that get generated from the RTC, and it gets pulled to that output, right? So yeah, we have to check that what we have to type over here. So basically whatever thing that you have to perform to check that alarm has got executed. So let me type as HAL underscore GPIO right pin, and as that pin was PF5, so I have to select the port as A, and the GPIO pin is actually this must be capital pin underscore, the pin number was 5, and I have to set that state to set, right? Okay, clear. Now this thing over here, is going to glow that LED when the alarm has gone initiated. Actually, when the alarm has got initiated, it comes to this function and perform if there is anything over here. So yeah, we have this statement. Now this thing will get performed and our LED will glow. But please notice that you people cannot use any kind of delay inside this, because that delay will not work, actually not work, because this action is a very small time period, because it just have to go to that line, it has just to touch it and come back, right? So that is a very small duration of time. So at that duration you can't use any kind of delay inside this function. So yeah, you people have to figure it out that how you are going to reset those LED, right? So yeah, you have to check that if that alarm has blown, so it does not get blown from for a long period of time, right? So it have to be of a certain period, right? If LED has blown, it must not mean that it is glowing continuously, right? It must stop somewhere. So you people have to figure out that what we should introduce over here to tackle that problem. So you can comment it down in the comment sections, and we'll be seeing your replies and we'll be awarding you accordingly, right? If we get the correct answer of this, we'll surely be gifting you something, right? So now let us go back to the main.c and let us check that does this thing perform good or not. So let me build this. Okay, so my build is successful. Now I have to debug it and upload it inside the board. Okay, so the code is successfully updated. Let me open the Terraterm and press the reset button. Okay, so now when the time will reaches to 0010, that is the new day time and the new 10 seconds. So at that time, my LED will glow. Okay, so at exactly at 10, my LED has glowed. So it is glowing continuously. I will be showing this to you in a video, so you can see that video now. Okay, so you have seen that video. Now, in this video, you have seen that LED is glowing continuously. Now, you people have to tell us that how we are going to tackle this problem if we have to, if we just have to glow an LED for 1 second, right, and then turn it off. And I have already told you that we can't use any kind of delay inside the IRQ handler, right? So yeah, you people just think about it and comment it down. We'll be shortlisting some kinds of comment and then telling you the winner and also awarding him, right? So thank you very much for today. Uh, it was fun teaching you, and if you like this video, please subscribe our channel and hit a like. And if you wish to see such kinds of video in the future, please comment it down, and we'll be surely helping you, no problem, right? If you people have any kind of doubt, you can then also comment it down. We'll be answering you surely.